The Bamboo Research Group, or BRG, at IT Delhi began its journey in the year 2008. Since inception, the research goal of our work has been to integrate the traditional knowledge system involving bamboo with modern structural engineering practices. Bamboo has been traditionally used in India to construct houses, but what is lacking is the knowledge of modern structural engineering. So our objective is to fuse the two together so that we can rigorously analyze, design and build bamboo structures based on accurate structural analysis and the known behavior of bamboo material, so as to ensure a very definitive factor of safety against loads like heat electron structure, the dead loads, the post loads, and the seismic and the wind loads. So when we began our journey in the year 2008, then in the first 5 years, we carried out research under World Bank funded R&D project under the National Agricultural Innovation Program, or NAIP. And the outcome of this was light patterned bamboo system. So this is a system involving bamboo combs which are bound together using patterns which could be either steel or it could be bamboo. So these sections are very much suitable for lightly loaded or moderately loaded structures such as sheds. 2013 onwards, we began working in a very important direction, that is fiber reinforced bamboo composite. So this fiber reinforced bamboo composite, FRBC, it offers a system with very high axial and flexural capacities which are comparable to reinforced concrete. This can enable construction of frame-type structures which are optimal for seismic and wind resistance. So we brought this forward since 2018 as part of our REPUTED 2 funded project, as part of which we constructed a proper 3D prototype structure consisting of FRBC frame, and this was supplemented by bricks made up of Cow-Dung, which was sourced from our collaborator. So overall, this whole structure, which you can see on my back side, is a carbon negative structure and very sustainable in nature. So I am very sure that FRBC is best bet towards sustainable built environment. FRBC technology is very much suitable for wide-ranging terrains and climatic conditions, especially for the Himalayan region where the particular seismic zone is zone 5. And on account of the rampant constructions, we are already witnessing a lot of adverse effects on the environment. Please watch this video in full so that you know about the opportunities for R&D collaborations and for technology transfers in the field of engineered bamboo structures. You'll be glad to know that we have filed patent for the FRBC technology and the technologies right now available for transfer.
The cement and steel industries play vital roles in infrastructure development and economic growth. However, their operations have also been associated with significant environmental challenges, primarily related to pollution. Production of 1 ton of cement emits greater than 1 ton of CO2 in the atmosphere. Production of 1 ton of steel emits greater than 2 ton of CO2 in the atmosphere. Sustainable development refers to a concept that aims to meet the needs of the present generation without compromising the ability of future generations to meet their own needs. It recognizes the interdependence of economic growth, social development, and environmental protection. The concept of sustainable development gained prominence in 1987 with the publication of the Brundtland Report, also known as Our Common Future. The report defines sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Sustainable development encompasses 3 main pillars: economic, social, and environmental. These pillars are often referred to as the triple bottom line. Then, to achieve the development sustainably, we come up with the project of development of engineered bamboo structures technology for modular rural housing towards sustainable built environment. This project envisages the mass utilization of bamboo coupled with the knowledge of structural engineering to devise an affordable house suitable for both urban and rural needs. India is a fine land of tradition and culture. It is not only the second largest producer of bamboo in the world, but also has an outstanding community with a vast knowledge of traditional bamboo technology. The concept of using bamboo is an affordable and environment-friendly structural material with suitable properties for use as a structural member. Bamboo is the world's fastest and strongest growing woody plant and an enduring, versatile, and highly renewable resource. Its versatile structural property makes it highly suitable for the construction industry. Fiber Reinforced Bamboo Composite, FRBC. FRBC was invented by IIT Delhi in 2013. It involves a collection of bamboo culms as a matrix bound together by mixture of polypropylene fibers and epoxy adhesive culminating in fiber reinforced bamboo composite beams and columns. This resulted in a monolithic core which was very strong and stiff. Concrete bricks and tiles. The concrete bricks, made up of cow dung, lime and clay, are durable, lightweight, and, therefore, perfect for wall paneling. Since these bricks are unburnt and made from cow dung, lime and clay, it has zero carbon emission and net zero embodied carbon. Impacts of research. 1. Switching to sustainable construction. A. The development and usage of FRBC and HFL sections after adequate modifications and testing of their structural performances have enabled the replacement of traditional RCC beams and columns. 2. Reducing carbon footprints. Bamboo and concrete are carbon-neutral materials, so its usage has enabled it to achieve zero carbon footprints. The bamboo absorbs carbon dioxide during growth and produces 30% more oxygen than standard trees. 3. Sustainable agriculture practices. Using engineered bamboo as a stable structural substitute to traditional RCC will promote the harvesting of bamboo by farmers on a commercial scale. Bamboo matures in just 3 years compared to standard timber, which takes 10 to 15 years to mature. 4. Social impact. Using bamboo and concrete in construction positively impacts society by providing safe and affordable housing for communities in need.